some kind of a bug to connect onto this, some kind of a, because this is going to be the main, oh, it's not quite large enough. We need a way to bug onto this, because we have some other cable that's going to intermittently connect into this other system, and if you have something we can bug onto this with, it would be good, like some kind of anything, just as long as we can, even if you have to get some kind of a nut and bolt, one set screw bolt that holds the connector down, and we put that on top of it. And this unit here is specifically made as a, this is a nut that goes on top of it here, and this has several purposes. To screw this down so it's finger tight. Don't have to reach anything down, it's fine. And the coil comes with now, the way I've designed this coil is, no one, we talked about how you're going to use it. I have this designed so that it's relatively safe. I mean, let's be frank, right from the start. Are you recording?
Yeah.
Stop. I did a very big program some years ago for the this room here get a lot of steel in it, the roof is steel, so the issue here is we'll probably get no interference outside this building at all. In other words, nobody's going to call up and say, I can't watch, but soap operas today, there was something going on, you guys doing something up there? And you can honestly say, are made, they screw in, this is one for the effect of a direct lightning bolt going up. That screws right down in there. That's just a piece of threaded rod. You don't have to tighten it down. Just put it in a little bit is fine. That sticks up. We'll shoot off that way.
It's connected.
Great. Yeah, that's fine. I would, let me see.
Work. That'll work for opening.
Yeah. Yeah, we can.
The copper rising under it.
Yeah, I understand that. Just looking at this can tighten down. Okay, you can apply that in a minute. Let me get that. This is designed so that you can start this down into here. You get this thing down and we can turn it around. And it does this so you can rotate this. You don't have to tighten this flat. This can be rotated, anywhere along you want to point the spark. And this is a major safety feature because if you want to run the coil here, you want to point the discharge to the side or out into the audience or whatever. You don't want it to go off behind, which you can randomly discharge from the toroid. So it's not, they've had this tuned and designed to discharge off these. You have this, and you have a shorter one, which will hold back closer to things so you get discharges off both. But these are built so that you can.
If you have a person in the middle of power, you can know what's happening.
You can run this in low power. Could somebody be able to take a spark off that thing and use a long fluorescent tube and fool with it close up? And that allows you, instead of, see, a lot of these bigger machines and so on are built so that the things are, you just turn them on and that's, good for boom, but it's not good for education. You can't show, you can't tell. You slowly and carefully leave the coil attached. If you're going to go any distances or anything like that, you have to wrap the coil like I said. You really have to take, because if you cut or okay, so what we do is we have this goes up here with the washer, and then we have a nut to go on here. feel no just regular iron or anything like that with these things because it causes problems. Always use brass. Brass doesn't rust, it has always a good connection, and that's really what you want to do. So what you do is you put this thing right up here. You don't have to murderously tighten it. Just, tighten it down. Finger tight is fine. This here is a ground connection. Okay? We'll write all this down and go over this. And we'll write it down. So what we do is we just simply take this ground connection and put it over this. It stretches tight, so if it seems a little tight, don't hesitate to pull it. It's inside of it. And then you put another bolt underneath this thing when you get that tight, see, like this. And you just bring that right up so that that's, again, finger tight. Okay? That's tight. All right, that doesn't really matter which end goes where. I would imagine that probably if the longer side, these are regular RF connectors. Just push them right down. Don't have, just finger tighten on to reef anything down. That's just, yeah, that's fine. Then with the insulator to the bottom, okay, like this, the insulator to the bottom. We then carefully, this is fragile. You want to tighten these things down. Okay, that moves. See what that, screw that again. Okay. And then turn the coil so that it's straight up to it. And then we can pull this back so this is just not tight, just off the ground. That's fine, just like that. Okay? Now, this is the direct current connection which runs the rotary spark gap wheel. This is a special shielded cable, and it's shielded so that the RF current generated by this is grounded off and not taken into this copper shielded cable. So we don't get any RF current in the system back there, although it's filtered. So I have everything filtered all the way down the line, which I'll explain to you, so that the RF stays out of the system completely. Demonstrated rule of this thing. Just wrap them up. Okay? Screw up. Let's take that in over there. See what we got between. We're not having a tangle. We do. Okay. That goes over right to the control unit. Okay. Now just actually lay it down. I'll show you the whole thing. Or if you come to the right, to the other side over here, you'll notice that there's a socket. Plug that right into that. Okay. And on the back here, this plugs right into here. Okay? Just like that. And then on each piece of equipment here, you'll see there are ground terminals. And what you can do with these everything has to be well grounded. Is to ground the base of the coil. And that's done simply, just take this narrow cap off here, put it in here like this. Actually, should be a washer with that. AC1 is a lower inductance coupling, which means that it was built that way so that if you want to just run at low power, want to run some low experiments, you can get a little more current through the thing at low power to run it than you can at AC2. AC2 was built so that the inductance that's in, there's a series inductance in there to limit the current that goes to the transformer. The series inductance was in there so that, you know, a closely coupled transformer like that, if you just, you know, put juice to it, it'll draw huge current. You want to be able to limit the current so we don't get any saturation. So we have a thing that'll sing a good tune. You'll hear it run, you know, what it does. But AC1 and AC2 are just something, if you're gonna run the thing with a small discharge and a light bulb, let people get up close to it, you know, get a light bulb, oh, you can fool with it, but I mean, you know, and also with these connectors here and stuff, this is something I have to talk about. You know, you can run the connector right under the coil, so you have everything running straight back. You want to sort of get a game plan back there of whatever you're comfortable with, so that when students, observers, customers, whatever, come in here, that they are approaching this thing from an area where they're not getting near any terminals, they're not getting near anything that has to do with the connectors, because if somebody goes like this and stands on the ground without by mistake and touches it, you're going to get a surprise in your life. It's going to rectify a big DC shot. Because when you get a ground out of this, with any AC current, you're going to get rectification. You're going to give yourself a handsome little shot. So I guess you got that thing on, don't you? Then you go to this over here. And the only thing we want to make sure of is that we do not get this near that. So, you know, we're okay. This is fine, but, you know. So that gives us our hookup. So we want to make sure that this is hooked up, the ground connection is hooked up. We have our DC connection, our AC connection, our ground wire running back to ground, and also from ground ties the control unit and the power unit together. Now when we have that, it's like flying an airplane. You want to make sure that that stuff is checked out perfectly. What's the voltage output here? Is this a three-phase system around here, or is this single-phase 220, 240?